Welcome, everybody. Welcome to our webinar today. Be joining slowly here over the next couple minutes. We'll take just a couple minutes as everybody's getting joined, and we'll start in just a couple minutes. Hi, good to see everybody. I can see more of you joined. Yeah, we're just going to let people come in here just for a few minutes, make sure that everyone's here that's planning to be, and then we'll embark together. So just give it a moment. As we're waiting, good to meet you. My name is Alex. I'm the marketing director for SimSystem Americas. I'm not going to be your presenter for today. That's going to be Jimmy Ashlock. I'll introduce him in just a second. But just if you're getting acquainted here, just so you know, today we're going to be having mainly a webinar where Jimmy's going to be going over Make&Mill, our hybrid solution. And then have some Q&A at the end. So just be aware that we've got a Q&A box at the bottom. You can put any questions in at any time. But I'm going to share my screen, and I'll share a little bit about SimSystem and who we are, and then we'll get going here. So let me share my screen. Okay. Well, welcome. Like I said, my name is Alex Berger. I'm the Director of Marketing at SimSystem Americas. Tell you a little bit about who we are. Welcome to our webinar. This webinar is called Hybrid CAM Solution, Exploring the Future of Dental Manufacturing Workflows. And with us today, we have Jimmy Ashlock. Jimmy, say hey.
Hello, everyone. Hello, hello.
Yeah, Jimmy is a tech expert working with Make&Mill. One of our products here, I'll go over what our products are here in the dental space. But Jimmy's been a technician for 3 years. He's lived in both Italy and the US, but from Italy originally. Yeah, is a great technician for us, helps a lot of people around the world with their Make&Mill technical just needs. So we're going to be going over Make&Mill today. So let me tell you a little bit about SimSystem, who we are, what we're about. SimSystem, we're a CAD/CAM software developer based out of Milan, Italy. We started in 1999, a long time ago. And you can see the cathedral here in Milan. And we have just several different products. If you're familiar with our dental product Mailbox, which many people here might be, just because it's connected to all the same parts and everything. We have several other software solutions. So we're actually a in-house software developing company, which is an advantage for us because we're going to we're going to implement all of our own changes into the software ourselves, do our own development, so we can create products like Make&Mill. Yeah, our solutions are really aimed at having a lot of built-in automation and have all the features that you need for dental workflows. And they're built for each market. So these are built for dental specifically. So the software itself is made to integrate with all the latest machines and technologies that are available in the dental market. So we're actively developing the software all the time. With that, we're with several different locations. So I'm actually in the USA location. Jimmy's over in Italy right now. Italy is our headquarters in Milan. And we have several other offices in Germany, China, Thailand, in Asia. Yeah, here in the USA, we cover the Western Hemisphere. So that's a little bit about us. You can see some stats. We've been doing it for a long time, have a lot of different software products, a lot of just partners, and yeah, we're all over the place. With that, I'm going to pass it over to Jimmy. He's going to talk about Make&Mill, which is our hybrid software solution. Yeah, Jimmy, take it away. Thanks.
Okay, thank you very much, Alex. So, can I share my screen? So let's see if we can get this working properly. Be great. Can everybody see? Can you see? Am
Yeah,
I
we can
good?
see. Yeah.
Okay. So can I start? Okay. So hello everyone, and thank you for joining today's webinar on Make&Mill system. My name is, as Alex says, Jimmy Ashlock, and I work as a CAM technician at Sim System. And for those that don't know me, before joining the software industry, I worked over 20 years as a dental technician, gaining hand-on experience with digital workflows and restoration processes. After that, I spent 5 years working with a CNC machine manufacturer for dental application, which gave me a deep understanding of how the manufacturing technologies work. Since 2021, I've been part of Sim System team, where I mainly focus on technical support and on user training. I try, and I hope I do, help customers solve practical problems and improve their daily workflow with our software tools. So today, the main goal of this webinar is to help you understand how to get the most out of Make&Mill, from importing STL files to generating toolpath, especially on focusing on how this system helps dental labs prepare models for milling quickly and in a correct way. Okay, so we already talked about Sim System on how to say who we are and what we do, but I want to say something about Make&Mill, that it has been developed in 2021 as a mailbox add-on module. Today, it can be installed as a standalone software, which allows within a single software to use of two different technologies, additive and subtractive, providing users with a unique benefits like optimized processing times and repeatable accuracy and product parts and producing parts. Make&Mill guides dental operators through the nesting process on the sintering. Let me see, change this, excuse me a minute. So okay, Make&Mill guides dental operators through the nesting process on the sintering machine and produce toolpath for refining printed restoration on the mill. Once the object has been created with additive technology, the Make&Mill solution allows the object to be milled automatically, identifying only the parts that need to be finished, resulting in a reduced tool usage and shorter execution times. Okay. Why use Make&Mill in the district? Dental labs need speed, precision, and constancy. So we can reduce operator time, standardize preparation steps, and improve output quality. It's ideal for a variety of restorations like crowns, bridges, abutment, and more. With Make&Mill, your STL file is not just a static model. It becomes a dynamic starting point for precision, efficient, and high-quality milling operations. The workflow is designed to adapt to different clinical cases and user needs without compromising on speed, reliability, and both streamlined and customizable. What makes Make&Mill stand out is the intelligence behind it. It's not just about toolpath, but the smart strategies that simplify complex tasks. Within the models, you don't have to choose between accuracy and speed. You get both in one constant integrated system. The transition from 3D model to an actual machining strategy is quick and intuitive. Make&Mill handles the complexity so you can focus on the result. Okay. So the Make&Mill workflow consists of 4 simple steps. It's to import your STL files, orientate it and align the part, generate the support base, validate and export the result. Everything is fast, visual, and you can work with one or multiple parts at once. So now I will show you how to load a dental STL, orient it correctly, add the support, and prepare it for a CAM export. So let me real quick open. I have to go out from here a second. And let me see how we can do this. Excuse me. Yeah. And the presentation. I have to do this manually. Okay. So this locked down on me. Let me open it back up. So I'll show you how to load the STL and all the procedures. But the important things that I want to say is let's start talking about the look at Make&Mill's interface. At the first look, it's very similar to Mailbox, and I hope there's a lot of you guys that's using it, so you already know what you're seeing. Okay. And let me get this way out the way. I want to see this. Okay, so it's real similar to Make&Mill, to Mailbox. And that's definitely a plus for users who already are familiar with this environment. But even for the new users, the interface is extremely intuitive. It's designed to simplify the entire two-path creation process, offering smart automation for automatized parts and positioning the pieces, okay? The software is built with easy of use in mind. Most operations are straightforward and the learning curve is really short. So even new operators that just start with this product can become productive really, really quickly. Okay, so on the right side of the screen, you can see we have all the icons that guide us through the workflow step by step, okay? From the new job importation and blanks and everything else, okay? And on the left side, we have the configuration tools, and more importantly, all the function for managing the machine strategies, such as modification and other accession operations, okay? For this demo, I will be using a mixed set of examples to show you the main features of the software. I'll focus on particular on the abutments where we'll explore different ways to manage the implant connections. We also see how to replace functions, the replace function, both by importing the connection manually using the automatic import options and other things, okay? So let's begin by clicking on the new job, okay? Here we see a list of all the machines configured in the software. We also have the option to switch tools if needed. So all you have to do is click on the little wheel here and you will have, if you have other toolkits inside the software, you can easily change your toolkit. Most important thing is that you will always see exactly which toolkit you're using, okay? So once we select the machine, all we have to do is select the material we want to work on. So in this case, we want to work on Chroma Cobalt, and the fixture will show up as the fixture that we will use will show up, okay? Notice the small icon next to the fixture. This is where we can enter offset values for the calibration. On this, we'll come back on it later at the end of the session, and I will give you more information on how that works, okay? So now we can confirm and move to the next step is by importing a STL. So all we have to do is give it okay. Okay, so here we have the interface where we have all our STLs, all the information we need. I'm not going to stand here and explain everything because we don't have that much time, but it's just like Mailbox if you're already users. So we're going to start with an aesthetic round. So it's really important. Okay, let me step back real quick and say one thing. Here is very important to assign the correct object type to each STL, because that determines the right strategy and triggers the correct automatic recognition process. So said this, we can start. So here we're gonna click on the first one is a static crown, and I'm gonna have to pick the correct object. So I'm gonna go to a 4 contour crown and start loading it, okay? After that, I will load a unit, a 4 bridge, anatomic always, so I will go to 4 contour bridge and load this one as this object. Then I will go to a 3-unit bridge for ceramic layering. So here we go to a framework bridge, give it okay. Then I will load the external abutment and an internal abutment at the same time because they are same object, so I can pick them both together. Click on the object, load them, and at the end, I will click on a bar where we have some attachments so I can show you how to manage those as well. So once we got everything, you just all have to do is confirm. And as you can see, during the import process, the software automatically analyzes each object. Thanks to the built-in automation, features like holes, curves, and surface are recognized correctly without any manual input. In this case, I imported all the objects together with any construction info. I mean, I'm not using any construction info, so all the detection is handled entirely by the software recognition engine. And if you prefer, you can import one object at a time, so it's not a big difference, okay? What you're seeing right now is, unlike Mailbox, the nesting here doesn't happen directly in the working area, in the nesting area. Instead, the initial import part places of the object are randomly inside the interface space. So before reviewing each part in detail, I will proceed with a nesting so we can arrange the parts properly and ensure everything is correct position for a good analyze, okay? if we look at our interface, there's a couple things that we have to say. So during the nesting phase, it's very important to pay attention to these red rings. These rings are reference rings. These rings are used to properly align the net inside the fixture for the finishing step after our project has been printed. As you can see, the reference rings come in different sizes. So if you can see, this one is a little bit smaller, this is another size, these two are the same. So there's 3 sizes of reference rings. And it's recommended to include at least 2 of them of different size in the net. This helps ensure the correct orientation and avoid any positioning mistakes during the milling process, okay? So here, let me go here and I will grab this bar here and bring it down here. You see all the elements are red when they're outside the nesting area. So when you see anything that's red, it's not correct. So it have to be, everything have to be the right color, okay? I'll bring this over here and I will turn this one like this. Bring it down here like this. I will grab this one and turn it around. And so I will put it right here like this. We can get this one here, put it over here somewhere like this. And we'll grab this one here, put it over here like this. And we can grab this one here and bring it down here. Okay. So once we have everything about set, we can start to analyze our object. So first, when it comes to implant connections, the software automatically creates a protective layer around them, as you can see, okay? This layer can be easily shown or hidden using, in our tabs in Tools, Show and Hide menu. You can hide the protection if you want, or even faster, you can use keyboard shortcuts. In this case, it's Control-P, and Control-P stands for protection. So if I click on Control-P, you can hide and show the protection. There's other keyboard shortcuts, and the software is really easy to use for this reason too. So now, on the other hand, for the cavities and emergency profile attachments, similar features, protection need to be applied manually by the operator. Let's now go through each object and verify that all the features have been correctly recognized. Things like prep lines for cavities and curves on implant connections. As you can see, each cavity showing its own correct prep line, and this bluish color. So we know that all the cavities has been identified correctly. So as we can, and if any of it's important to say, if any of these had not been detected automatically, the software includes dedicated tools to perform the recognition manually. And it's always in Tools and inside Curved Surfaces. Here you have all the tools that are needed to change or to modify eventually something that is inside the object, okay? So it's something, if you're a Mailbox user, you already know this because it's exactly the same thing. So it's real easy to use, okay? So let me exit real fast here. So as we can see, each cavity is showing its own prep line. And the arrows on top of each cavity indicate the insertion axis of each cavity, okay? On the occlusal side, we have arrows as well, but these right here are, especially for abutments and bars, represent a secondary insertion axis, which will be used for machining the outer surface if selected, in this case, for Make&Mill, okay? So now let's begin with the cavities. We will apply the protection layers of all the materials that will later be cleaned during the machining, okay? So I will spin this around like this. Okay, so to add material to the cavities is real easy. Always inside Tools, Curved Surfaces, you have a dedicated tab called Add Protection Cover to your cavities. In this case, you will have different options where you can work on the cavities. And the first thing you can see, you have the protection thickness. So you can change this thickness however you feel, okay? Or better, what you need. I mean, 0.3 usually is good. 2.5, 0.3 is the correct usually what people use. I mean, okay. So when after that, you can apply the protection to one cavity, or you can apply to all the cavities of the same object, or you can apply the protection to all the cavities all in one time. So you have different type of options. In this case, I have applied the protection to the clicked cavity. So I will click on this cavity and he will create a layer thickness of 0.3, okay? So if I do this type, I will go on this one and click on it and he will apply the layer on both cavities. Okay, and let's say on this case here, I want to change on the other bridge, I want less. So I can give it 25, 0.25, and he will give him a thickness of 0.25, okay? Okay, once we do that, the next thing we wanna do is move on to the implant connection, okay? So as mentioned before, earlier, the software already applies a default protection layer around the connection. This is a generic protection that covers the entire area of the connection, okay? However, different types of protection can be applied depending on the technical needs. For example, we can apply a uniform layer of material, and I will do this on this one. So in this case, what you have to do, you always have to go in Tools, go in Connection, and here you have a tab called Protection. You click on it, and you have two different options. One is for, like I said, just mentioned, a uniform layer, and the other one is for, I will call it a customized individual connection protection layer, okay? So we will start with the first one. We'll click on the connection. As it says on top, it will say, please select the interface to add the cover, and I will add this one. So he will ask me, first of all, how much material I want to add, okay? I can change it by clicking on the plus, or I can directly write it, okay? So just give it okay, and he will automatically change the layer on the connection. As that, we will see the customized protection. You can create a customized protection as well. So in this case, I already have built one, but I will show you how to build one. So in this case, I have, this is a Biomet 3i hexagonal 4.1. But if I want to create another layer, I can just click on the plus and just give it a name. And as you can see, if you look at it, you can see it under changing the dimensions. You can change and applicate whatever size you want to give to the protection, okay? So I'm not going to apply this one because I already have one, and I will give it just okay, and just give it okay, and he will change like this, okay? Now I'm going to do the same thing for the bar over here, and I will go here, and I will apply this one, okay? And I'll do the same thing with this one here, okay. Okay. Now, I will show you how to applicate all of these options, always a protection with the use of a replace system, okay? First of all, let me say one thing about the replace. Replace in Mailbox, the replace function is an advanced tool used to substitute a portion of STL model with a predefined geometry. In this case, we're talking about implant connection, okay? It's typically used when the original model lacks of precision construction data, or when the connection area doesn't meet the standard milling requirements. What I mean, like for example, we have different size of holes, or we have different dimension of the connection itself. So what I will do here, I will import first one that I want to say here. Okay, so we give it abutment. So replace can be performed in two ways. The manual replace, where the operator aligns and matches the replace part manually, is exactly what I'm doing right now, okay? So here, right now, what I'm gonna do, I'm gonna take the protection away so we can see what I'm doing. And I will go in Tools, go in Connection, and I will click the tab Replace. I want to replace this connection, and I will replace this connection that is a Biomet 3i certain, and I will connect it, change it, replace it with a custom one that I made with different size, okay? So all I have to do is give it okay. Here, and once I give this okay, he will change my interface. And when he changed my interface, he will ask me if I want to apply a custom cover to the select interface. As for the other way, he will ask me in automatic. I will pick this one, and he will ask me if I want to apply this to all my replace when I use this exact replace. I can tell the software to use it permanently for this type of connection. I don't care at the moment, so I just say no. Okay. So this is another way. The last way is the automatic replace, where the software recognizes the connection and applies the correct model automatically. So it's really important to apply this type of automatism. It's important that you have the STL with the construction info, okay? Because inside the construction info, you have the information that you will need to export and put inside a folder in a file name reference file where you will write the name, the exact name of that connection, and give it and match it with your replace. So I already did that, but once you do that one time, and then it's always good. So when you all have that type of connection, all you have to do is give it okay, and he will in automatic change the connection without you have to do it manually. Okay. So as you see right here, he imported it and he transformed it in a replace, and here already put the protection cover on it. So now here, what I want to do, I want to position these in another way like this. And I'll put this over here like this. Okay, so once we apply our replace, we can add material. Okay, we already add our material. Now let's move on to the additional of material on the emergency profile areas where needed. So this step is useful to ensure proper protection and clean milling in zones where the geometry transitions between the implant and the soft tissue. So I want this area here that have to be green. If it's not green, you can make it become green. You can auto design it and tell them that this is an emergency area. So here it's just simple as everything else. All you have to do is go in curving surfaces. You have a tab where it says edit abutment emergency area. Okay. Here you can remove it if you want to not work it. You can draw it, or you just have to go here and add it. If it's already drawn, it's already green. Here you have your size changing if you have to. And all you have to do is click on it and it will automatically give it its protection layer on top. Okay. So, okay. So in this case, we need to manually define the attachments, okay? Because here we have two attachments right here that we need to work on as well, okay? To define the attachments, so the attachments are milled. So let me step back a little bit. So when we need a manually defined to the attachment and proper insertion axis, so that the attachments have to be milled correctly and with the right tool orientation. So to define the attachment and the correct axis, we use a dedicated function found under always curves and surface. I will exit, so I will show you again. It's always the same tab. So you go back in here, go back to curved surfaces, and you have these two functions here that's for these type of recognition. So what you have to do, the first thing we're going to do, we're going to create the curve for the attachments, okay? So what this does, this will apply, it will automatically tell the software to apply the part of strategy to work on these two connections with a specific strategy, using specific tools. So you can use smaller tools to get in the smaller areas without using the main strategy, without using the tools always in the main strategy. So what I'm going to do here, I'm going to click on it. And here you have two functions. You have for locators, in case we have locators on top. In this case, we have attachments. So I will just click on attachment. Here is asking me the diameter of the offset to give to the attachment, depending on the size of the attachments. Usually 5 and 6 is always a good measurement. And in case it's not good enough, or it's too big, all you have to do after you apply it, go to undo and redo it with a different size. So in this case, I will give it 6. I will go exactly on top of my attachment. I will click on it and he will create my curve, okay? And I'll do the same thing on this one here. Okay, so he created 2 curves. They're inside. So right now, the software will apply the strategy to work on these 2 attachments. Second thing I want to do, I want to have a correct axis for these 2 attachments. So I will go and give it a secondary machining axis. How? I will auto detect it by giving it 2 points because I have 2 flat surface. That's the best thing to do, okay? You have another option that you can assign the secondary axis by view. By view means you position yourself where you think is pretty much parallel and you can click it from the view, okay? But I prefer if I have 2 flat surface, I prefer using this function right here. So I will just click on one, close it up, go over here and click on this one on top. So probably this axis here is not going to change because software probably already put it in the correct position, okay? So once we have this done, all we have to do now is start working on our supports, okay? So we can exit and we have everything ready. So I will go to my next screen to do it faster. Okay. And just a second. This is the online problems. Every once in a while it happens. Okay, let me go back here and here. Let's start here. Well, we can do it from this one here. It's not a problem. Okay, I'll go back to this one here. We continue on this one right here. No, one more thing that I didn't do. I didn't recognize the anatomic parts because here we have the possibility to work the surface of the crowns where I want this anatomic part to be finished correctly. This is real easy as well. As always in tools and surface, if you go in curves, you have this option here is offset mesh. And here you have the possibility to paint directly the area that you want to mill extra, or you can fill the whole area. You will fill the whole area. You have other options where you can delete the part or you can clean everything. If you made a lot of mistakes, you want to restart from 0. In this case, I will use the normal brush and I will just paint the areas that I'm interested in milling. So I will go here and I will just do this part here and give it some color like this. And here like this, I will do this like this. It's real quick, real fast. There's nothing. Okay. 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 Clean this up here. All right. Exit. Okay. So now we have all our parts ready, and now all we have to do is go to the support section, okay? So the supports manage it and Make&Mill. It's really important to know that the software provides a range of support types that can be added to stabilize the object during the milling. These supports are really crucial, especially for long bridges, bars, or thin structures that might deform or vibrate during the milling process. So it's important that you work good on this part here. So here, all we have to go is go in supports, and this tab here will open, and you will have their interface for all the options you have for the for the supports. Okay. The first one that will be active is to add the support. So as you imagine, all you have to do, you can add the support, okay? In case you have to remove the tooth, because from here you have to click on this part here where you can move the tooth again in case you want to change the position, okay? The edit support is for editing a support, like if you want to change it or you want to delete it, so you have this option here. These two options here are the parameters of the size and the shape of the support connectors that you're going to use. So in the first case, you have the parameters from ring to object, okay? In the second case, here you have the parameters from object to object, okay? And from here, you can decide different parameters. You can change parameters and you can change eventually the shape, okay? So I usually always recommend to start from the reference ones. And in this case here, we'll go directly on the object. All you have to do is click on it and go directly to the ring, okay? So in this case here, we added this type of connection. You'll do the same thing on the other side, and you start like this with the process and just keep on going. Then you can just add one from here to here. I ain't gonna do the whole job. I'm just gonna show you real quick how it works because we don't have that much time. Okay, like I said before, from here you can edit if you want. And if I edit, I can click on it and I can delete it. Okay, and at the end, if you want, you have the possibility, the software allows you to decide to cut a support after the object has been milled. If you want to do that, all you have to do is go and add edit support cut. And if you go on top of it and click on it, he will create a cutting part of the strategy where he will afterwards cut that strategy. In case you just decide you don't want it no more, all you have to do is click on it again and just give it okay, and you can delete it, okay? So let me go real quick in the job. I know I have one already completed, so we don't have to stay here and do everything. So after placing and fine-tuning all the supports, okay, we are ready to proceed to create the printable files optimized for the laser melting or similar technology and for the toolpath generation. These files can be used for other printing output software, or it can be directly input to Pyramis, which is another our software with a single click, because the two systems are fully integrated, okay? So let me show you here. If I go here and I go back to supports, you will find yourself in this position here. And from here, like I said, you have this tab here is Pyramis, where he will transfer all the information directly to the other software. Or if you have another software for printing, all you have to do is give it okay, and he will create, after you give it the name, he will create the STLs that goes to the other software. And now I already have them made. If I click on one, excuse me, let's do it like this. I should have one. I was hoping not to make you lose all this time on this part, but we have to go here and I know I have one here somewhere. Okay, I go here, now open. Just give it a second. So let me do, while we're waiting the software to open, the other our software where the file level where we can see the mesh. I want to recap real fast the workflow of the whole process. So it's start in Make&Mill, design, add supports, generate printing and milling files. Then you push the part to another to create the STL for the printing software, or to Pyramis. Slice and prepare with optimized supports. You send to the 3D printer, build the part via your choice method, return to Make&Mill, refine the printed job with precision toolpath, okay? So Make&Mill, here we have the STL, so you can see where he perfectly added all the material to our connections, okay? So once we have everything checked, I can close this, go back here, I can close this, and here, I want to close this because it opened 2 times. And here, I got stuck again. Real quick, I have too much stuff going on. I need to turn something off. Turn all this stuff off. Yes, just making a mess. So once we applied everything, we have the tab where all you have to do is push the button to start building, and he will create the tool path as like normal Make&Mill. And all you have to do in the second moment is after you calculated everything, I always recommend to use the simulation of the material residual, where you can see that everything will be, because you still have to mill, that everything will be milled correctly. So I will go directly to a calculated job. This one right here. And this here is already calculated. So if I go here to start mill to simulation, it should show me the material. So don't get scared of the offset you see around. The important thing is that inside each connection, each cavity, and inside the connection, everything, we don't have no material. And on the attachment, so we know everything will be milled correctly. Okay. So now we can go back here real quickly, and here. So it's important to say that Make&Mill over time has become a key application to provide the user with a complete experience, which allows entirely to digitize the workflow through simple and integrated solutions. Okay. In fact, it's not only integrated in Mailbox to finish milling project, but it's also integrated in Pyramids. So you have the possibility to integrate printing and finishing is a significant step in the scenario of dental production, because it guarantees aesthetics and precision matches by speed and cost reduction. Okay. One thing I didn't say before is the Make&Mill is also adapt for base plates. What does this mean? You can use the method of, instead of the net, you can use the plate. Okay. It's the same solution as the net, with the only difference that the printed parts can only be taken from one side. This setup is similar to the net, but with one key, that you have to flip the part, and all the finish must be done from the top side only, because on that side we need to refine the screws. For example, the screw seat inside the implant connection, we need to finish those with the T-tools. Okay. So using the T-tools not only makes the operation possible, but also significantly improves the precision and the surface quality of the result. Okay. Last but not least is the calibrator. Okay. The calibrator is what we saw before when we opened the software at the start. We saw that beside the fixture, we had that icon where I said offset. Okay. So in the ears, now here's wrote new, but it's not new. It's been around for a while, but we've been working on it for so much time that I feel like to say that it's new. So when we are installing Make&Mill models, it is aligned with a zero machine point, which serves as a reference origin for all the operation. It might sound a little bit complicated, but it's not that complicated. In some cases, after maintenance, for example, the origin can be permanently lost, and the whole setup needs to be recalibrated. So to solve this issue, we use this tool called M&M Calibrator, and M&M is not a chocolate candy, okay? But it's a hardware device that helps us accurately find and restore the 0 point origin. There are different procedures depending on the machine. On an advanced machine, you might not even need this because you can use the touch probe. On other machines, you can run a cycle that we give you on a pre-calibrated reference part, then check the result, and the result to align the origin precisely. Okay. Last, I want to show you a couple cases that we have here. That's real cases. And on the left side, we have a Utah case with scan body inserted in the connection. In the center, we have the implant bridge. We have an implant bridge, a bar with attachments and some abutments. On the right side, we have a multi-unit and an implant case and a simple crown. Okay. So that brings us to the end of our demo. And as you have seen, Make&Mill is designed to combine powerful automatations, user-friendly control, and maximum flexibility. Whatever you're preparing a job for a traditional milling, hybrid workflow, or for full digital printing. From the intuitive interface to smart object recognition, from implant management to a toothpaste generation, the goal is always the same. Optimize your workflow, improve your quality, and especially save your time with a system that adapts your needs and not other ways around. Thank you for your attention and for joining me today. And if you have any questions, feel free to ask now or reach out forwards. And thank you very much.
Yeah. Thanks, Jimmy. Thanks. Yeah, he just mentioned that if you have any questions, go ahead and we'll take your questions. We can go all the way to 11:30 if needed, but there
Okay.
was one question in the chat, but it is actually a mailbox question. So for that person, I'm just gonna say we're answering that live, asking about undercuts on a bite splint not being able to fit using mailbox. Question we're happy to answer, but go ahead and just we recommend you reach out either to our support. Okay, great, yeah. And
I
maybe
can, if you
your
want, I can answer. It's not a problem.
sure, yeah, go ahead. Yeah.
Repeat the question. He needs undercuts
Yeah, so he
when?
says I've got a yeah, we'll answer it, sure. And then if anybody has any make and mill or other questions, go ahead and put them in now while he's answering this. So this question is that they have a bite splint that they've been trying to get rid of the undercuts, but they can't make it fit. Anyways, it might be one where you have to check the actual case. But any tips for improving
Let
fit
me
problems
see.
because of undercuts on a bite splint?
Okay, I cannot show you in this case here. I will open. I probably can show you from here. So in mailbox, as in make and mail, in tools, you have the possibility to activate the custom operations. Okay. So all you have to do is go in tools, custom operations. In custom operation, you have undercut 3+2 manual. What this does, it gives you the possibility to go and determine your undercut by painting it. Like here, I don't have undercuts, but this, for example, I had an undercut right here, and I just can go here and just paint it. Once I paint it, he will create insertion axis, and eventually on a disc, on a blank, he will open the offset. So the tool will go inside and mill that part. It's important that inside the strategy, you have the cop that are recognized with a tool. That's the only thing. But otherwise, all the undercuts, you can do it in this way. And the good part is if you have other undercuts, all you have to do is click on it on again, and you can get in the same position where you see your undercut, paint it, and he will create another phase where he will do the undercut with another axis. So this is the best way to manage all the undercuts if you have problems with undercuts. Okay.
Yeah. Perfect. Perfect. Okay, and I got him our support email. And then we have another
Perfect.
person asking a question, Jimmy. So this one is coming from an anonymous attendee. Is there any printer the make and mill process does not work well with, or can it be used with any printer?
That's a question we need to add to Luca Trevisan.
Yeah, yeah.
But
I think we have a
actually,
list, but yeah.
well, in this moment right now, we pretty much have all the printers inside, so it's not a problem because basically, if you export the files, STL files, if that machine has a correct its own software, and if that software work good, you don't have no problems. That's the important part. It's not making meal that decide which machine it works best or better. Is that software that machine work with need to work good. If it work good, it work well with us too, because all we have to do is give the STL to the other software, and that software will prepare the slicing part for the machine. So
Yeah. Yeah, maybe I'll speak to that too. I mean, we commonly see in the USA like Trump machines, like the TruePrint 1000 popping up. There are a lot of other ones, but if it's used for any kind, if it's an SLM
mhm.
printing machine, laser melting, and it's generally in the dental industry or you're coming across it probably is available or can be.
Okay.
But I say that, limited, of course. But I think the main ones that people are going to come across are ones that we're working with.
Yeah,
And that,
the only thing I'm not sure we are integrated with Pyramis software. So with
right,
Pyramis, we need to check that because we have a list of
right.
machines, but we're growing on that as well. That's why I said you need to talk to Luca. Luca is the one that follows all
Yeah, yeah,
the pyramids part, so he knows exactly which machines are working good with the pyramids. But
yeah.
on Make&Mill side, like I said, all you have to do export the STL and use the software that's good for that machine, and it's and then everything will work fine.
Cool. And maybe Jimmy, I'm gonna ask a follow-up on that. What about milling machines? Is there any limitation on which milling machines are compatible and kind of how does it work with Millbox or
Well,
Make a Mill?
at the moment, like I said, right now we're working with almost all the companies, and we are working with Make&Mill even on machines that work just with soft material.
Yeah,
So, for example, VHF, we have that working, we have Atom working, we have Diamac working, we have all the EMIS
yeah,
working.
yeah.
So we're pretty much covered on about everything. So
Yeah, yeah. And you just told me earlier today, you corrected me. I formerly thought you would need to do only the web. You could use the web for any machine because you don't have to do any touch probe or anything.
exactly.
And formerly, I was told that if you want to do the plate, like a build plate, that you would have to have a machine with a touch probe. But Jimmy, you shared with me earlier that that's not the case. Actually, you can
No,
use,
exactly.
yeah,
Yeah. Since we have that new calibrator system, now you can avoid the problem. And what happened that that system will find the 0 point of the machine. So when we go inside the machine and create the reference for the plate, it will exactly fit perfectly in that spot, and that spot is going to be in the 0 point.
yeah.
So that's another good part we have going on.
Yeah, that's good. So kind of boiled down all that to say it's very customizable. You can use
Exactly.
any mill in the industry, any, SLM 3D printer generally. Jimmy's saying if
Mm-hmm.
you use our 3D printing software, Paramus,
Mm-hmm.
it may, or, we want to check and make sure it's compatible. But again, you can bring your own 3D slicing software to the table here too. So,
Exactly.
um,
Exactly.
yeah, perfect. Okay, next question. Anonymous attendee is asking, can you use partial sprues to eliminate trimming afterwards? Like Mailbox, how you can do a partial sprue or pin.
Partial screw pin, yes, you can do it with exactly like the mailbox. It's about the same. It's the same thing. You
Yeah,
just have to go back inside, you just restart it, and
you can cut away as many
it,
as you
it cut
want.
away with whatever you don't need. You just cut it away and just recalculate it.
Yeah. Yeah, so just like Mailbox, because really it Make a Mill kind of
Exactly.
is
Exactly.
Mailbox. Yeah, in a way. Yeah, yeah. So
Like I
yeah.
say, now the big difference is 2025. I mean, actually, it was in August when we start working on it.
Yeah.
That Make&Mill is not more just a
Right.
module add-on. It became
Standalone. Yeah, yeah.
a stay-along software. So if somebody don't want just want Make&Mill, now they don't have to buy Make Mailbox and then
Right.
add. They can go directly and buy just Make&Mill.
Right. Which awesome. Yeah, absolutely. And so that kind of brings up, I'll ask our last question here. But then if somebody's thinking about that and maybe they don't even have a mailbox, or maybe they have some
Exactly.
pieces of the equipment already. Maybe they have mailbox and it's just an add-on.
Mm-hmm.
Or maybe they're just thinking, I might get a printer. I might, I already have a mill, whatever.
Mm-hmm.
What would be some of the most common use cases that like that have a good ROI or common parts that you see just in your experience with technicians? Like, what are
Mm-hmm.
some good strategies for a lab to implement this technology?
Well, I mean, there's a lot of things you can implement because it's something that's always growing. And I mean, like for example, just the Utah is something complicated. And I remember it was
Mm.
about 2, 3 years ago when it came in, and it was like, Jesus, how are we going to fix this? And now we got that. We even have a new tab inside just for the holes of the Utah to manage those holes when they're crooked, that are on the outside, so that you couldn't manage before because it was not recognized.
Mm.
So now you can do it manually. So I really don't feel like to say that there's particular cases, but I'd say everything because a lab, if he's milling crowns and bridges and that's it, make a meal, make you save a lot of money because it makes you
Yeah.
save really a lot of money. If you're milling bars,
Yeah.
stuff like that, and this is another thing. I mean, it's more complicated. Before you had issues in the past, you had issues that the material that was coming out from the laser, this was called a laser from the sintering, was not so good. It was not so compact. So you
Mm.
were having problems after in the oven, all this kind of stuff. Now
Mm.
they fixed that too because now the materials are so good that I really don't see that much of a
Yeah.
difference. I mean, so
Yeah. Yeah.
I think so if somebody thinks to implement it, is for sure you have to implement it for save time to optimize his
Mhm.
workflow. And I will not say to improve quality because that depends on the lab. Depends how they
Yeah.
work.
Yeah. Right.
Okay.
Absolutely.
So I will leave that out because sometimes we have labs that don't look too much at quality. But
Yeah.
saving time and optimizing your workflow is good for all the labs.
Yeah. Yeah. Any metal part that you need to produce. That's right. A
Exactly.
lot of. Yeah.
Exactly.
Awesome. Well, great. I'm not seeing any other questions in the chat. Um, Happy to contact with anybody offline. If you're contacting Americas, I put that in the Q&A at one point. Support.americas@simsystem.com. Jimmy, will you give us the support email for global? What do people need to contact?
Yes, it's support at simsystem.com.
Okay, so either support@simsystem.com or
Yeah.
support.americas@simsystem.com. Yeah, two
Exactly.
options there, depending on where you are. We'll make
That's
sure
right.
you can ask any question there. We'll get you to where you need to go. With that, thank you so much for joining us today. And yeah, thank you so
Thank
much,
you
Jimmy.
all.
Appreciate it.
Thank you. Thank you all. Thank you.
All right, everyone, have a
Okay.
great day. Thank you so
Bye
much.
bye. Bye bye.
Bye.